So coming to the internet model that we currently use is the TCP/IP protocol suite. This is TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. This is this details of these protocols. We will study it later in module 4 and module 3. So right now you have to understand that TCP/IP protocol is made of 5 layers. From the top, application, transport, network, data link, and physical. Now, what is application layer? It's a layer where human can interact. A human can interact with only applications because they are GUI based, or you can click with the mouse, or you can type something with the keyboard. So human can easily interact with the softwares running in this layer. To prepare an email, you log into your Gmail account or a Yahoo account and you type the letter, you write the sender address, the subject, and then you say send. So all that is possible only with the softwares available in the application layer. Below that, you have something called a transport layer. As the name goes, the role of the transport layer is to send the data, transport the data. From where? From source to destination. So whenever there is a conversation happening between two devices on a network, it implies there is one port opened in the transport layer, and from that port, all data is moving all the way to the destination transport layer. And that port will be open until the complete transaction is done. Once the transaction is done, the port will close. So if you have logged into your internet and you have opened an email to mail your friend, simultaneously you are opening a Wikipedia page and also you are downloading some file from a particular website, then 3 ports are opened. One port will deal with the email service. One port will, in application layer also you have 3 protocols, 3 applications running. Transport layer also 3 ports will be open. One port will be dealing with the email service. One will be helping you to download the web page content so that you can read. Another port through which you are transferring some file. So at a time, 3 ports will be open. It can be multiple ports opened in the transport layer. Then comes the network layer. So the job of the network layer is basically to find the shortest possible path in a network. Now, whatever data has come from application layer is sent through a transport layer. Now, network layer job is to make it reach destination. So it should find which is the best possible path. It should check if there is congestion in the network and take care to see that the data is going in the right path. So there are algorithms running in the network layer that take care of routing the information. And you get one address in the network layer, which is called an IP address. So IP address will depend upon which network you are connected, and through that IP address only, you will be able to reach the destination. The bottom second layer is called data link layer. It is also called network interface layer. Network layer is also called internet layer. Data link layer is network interface. Basic role of data link layer is it has 2 sublayers. One is data link layer, another is MAC layer, media access control. So the first sublayer, data link layer's job is to create frames. The packets are broken into frames. Frame are smaller parts to also ensure that some amount of flow control is done. Flow control means if transmitter is sending data at a faster rate and receiver is not able to receive them in the same fashion, then sender has to be signaled go slow. That is flow control. Actually, currently, flow control is implemented in transport layer. Okay. The second sublayer, MAC layer, its job is how do you access the shared medium? For example, I have 2 highways meeting at a juncture. Then how is the traffic managed on those highways? There is a traffic policeman who will be regulating the traffic, or there is some signal put that will allow everybody to use the road or cross the road for say 45 seconds or 1 minute. And when one set of traffic is moving, the other three should wait, something like that. So same way, MAC layer is deciding who will use the shared channel at any instant of time. So again, you have multiple methods in which the shared channel can be accessed. You'll study that in module 2. Network layer we will be discussing in module 3, and transport layer is discussed in module 4, and application layer is discussed in module 5. Finally, the frames prepared by the data link layer are given to the physical layer. The role of the physical layer is to transmit the raw bits. It basically decides the encoding scheme. Okay, what should be the voltage level of a logic 1, logic 0, the time duration of a logic 1, logic 0, and put that data on the physical channel. It may be wired or wireless. Okay, so that's the role of physical layer. It's basically dealing with the actual communication here. Okay, so here is one scenario where you have a source A which is communicating with source B. Okay, so source A has 5 layers in it. Source B also has a destination B also has 5 layers. They are both computers. You can see the diagram here. Now let us say physically they are far apart. A is in one country, B is in say another country. In that case, A wants to communicate with B. What does it do? First, it will prepare the data using some applications that are available in the topmost layer. It may be an email service or a file transfer or opening a web page, anything it can be. So it is preparing some data, it has prepared, and it from the application layer, it goes to transport layer. As I said, in transport layer, one port will open. So there are two types of service actually in transport layer. One is called TCP, Transmission Control Protocol, which is a connection oriented service. Means there is a dedicated connection all the way from source to destination, and all information of one particular application to one particular destination follow that path only. The other service is UDP, User Datagram Protocol, where there is no guarantee of service. There is no one route that is decided. Packets simply go through different directions and ultimately try to reach the destination. So since there is no predefined route and nothing is fixed, UDP is called an unreliable service. So you may lose certain packets on the way. Okay. So in the transport layer, one port is opened. It may be TCP service or UDP service, but one port will definitely open for the application that you have requested for. Then the data moves to network layer. In the network layer, as I said, it has to decide what is the best path for it to reach destination B. So it has understood that the data to reach B should go via link 1. Link 1 may be another computer. Then it should go to router. Then it should go to link to finally reach the destination. This is the path it has found. So what it will do, it will send the packets to a data link layer. Now data link layer will create frames and it will put the address of the nearest system and send it to give it a physical layer. Physical layer will put the data on the communication channel that will reach the nearest switch, that is L1. So in L1, the data goes from physical to data link. This will understand, this switch will understand this was the correct destination address, but it will also see the packet. In the packet, there is destination IP address. Can you see? So the switch understands the same data should be forwarded further. It is not for it. So it will send the data back to physical and it has come on the communication channel. In between, they reach a router. So Again, it goes into this system's physical data link and a router. See, this router, why it came into picture is, I said source A is on one network, source B is on a different network. They may be in different countries. So I need a connecting device to connect two WANs. Router is that device. So the data goes to router. So router sees, okay, destination is B. Still the packet has to go further. So what it will do, it will find the address of the nearest switch. That is the data link layer here finds the address of the nearest switch. It will add that address and send it to physical and again come over the bus. So again in the link 2, the data has gone through physical data link and it will see destination is B, not for itself. So it will pass the data. Finally, your data will reach the physical layer of the actual destination. So it will go to data link and then it will go to the network layer, IP addresses match. Then it will go to transport layer, port address will match. Then it will be delivered to the application layer. So you should understand one thing here. When the journey is from one source to one destination, intermediately your packet may go through multiple physical data link and network layers before it reaches the destination. But you can see in this entire process, there is only one transport layer at the sender and one transport at the receiver. In between, it will not go into transport layer of any of these devices. So we say transport layer is an end-to-end layer. Means sender transport layer is communicating with the receiver transport layer. Okay. Intermediately, they will go through multiple physical data link and network layers. They pass through that. If you are asked in the exam, explain the TCP/IP protocol communication, you should draw this diagram which shows you the physical data link and network layers in between. Okay. Don't simply write 5 layers. So same thing has been demonstrated here. Okay. So this is how the data goes. You can see. Again, I said peer-to-peer communication. So the information exchanged in application layer is messages, and information exchanged between transport layer is segments or user datagrams, and information exchange between two network layer is called datagrams or packets. Between data link layers, it is frames, and between physical layers, it is bits. What does this information exchange means? Between two Indians will exchange money in rupees. Okay. Whereas um, an Indian with European may have to exchange it with euros. So something like that. The unit of exchange will change from layer to layer.